Okay, good morning, everyone. Can I just get a thumbs up that you can hear and see the current screen that's being shared? Thumbs up. Okay, all good. So this morning, my colleague, Nomni Mfuphi from the CHPC, she's a research scientist, also doing a PhD. She'll be doing the Linux review because she enjoys Linux and Bash terminal so much. She was begging me to do a presentation on it. So I said, okay, I'll get to do that this morning. Yeah, so over to you, Nomli.
I'm using PC, sorry. So good morning, everyone. So I'm going to be doing just a recap of yesterday's session. So today we're going to be experimenting with chaining multiple commands in the same line just to see what will happen. So one of the powerful things about using the command line-based interface is how you can use one line of code to do more than one thing at once. This is done by chaining the commands together. So the power lies in what we call logical AND and also loops. So logical AND is simply typing the AND symbol twice. So that's what we refer to as the logical AND. Oh, sorry, speak up. Thank you, everybody. Is that better? So the first thing that you would want to do is obviously see where you're at, and we do that by using the command pwd, as we did yesterday. So this is my path. So say you have a new project that you want to work on, and you already have like the first line of code of your shell script in mind. So you can use the logical AND to just chain the commands together and make it one line. I'm just going to do an example here. Let's say I want to create a directory called my new project. And I want to cd to that directory. And sorry. And after cding to that directory, I wanna create a new file called my script.sh. So I'm just reviewing if I got everything right. And if I run this, it's just gonna open a new file, of which this is where I can begin to write my shell script if that's what I want to do. So the first thing that you would want to do is tell your system which interpreter it should use. In short, you're telling your system which language it should use to interpret your script. So I want my script to use Bash. So I'm gonna write my shebang, as Benjamin showed you yesterday. Sorry. And then say I want my script to equal something. So I'm just gonna write that line. Am I too soft? I'm sorry. So I'm just writing my lines of code. I can do this. Does anyone remember why we have that ending? Okay, I can't feel anything. So then I'm just gonna save my file. We can just switch the things around. They're confusing me. So I just want to switch the displays around so that when I do this, I can just go this way. I want to switch the displays around in the center of the frame of this, so it just goes this way.
You want to supplement it?
Yeah. It's confusing.
Right.
So it's sorry, I just want to switch the displays around.
Supplements.
It's about this way.
Oh, there you go. Okay, and just. We got it.
Bigger. Takes a little bit.
It's gonna console to make it bigger. So just save it.
Look, visible.
Fine.
Okay. So I'm gonna save my file. So now just to verify if all those commands here worked, I'm gonna present my working directory. And then list the files that are there. As you can see, my script is there. And then so I'm gonna try to run my script. It's or just ls and just see if I have permission to run it. As you can see, it's not executable. So to change that, I'm gonna use the command that we used yesterday, which is called change mode. So I'm just doing this to make my script executable. Then now I can run the script. So the whole point of those was just to show you that you can actually chain the commands together to make into one line so that you can run different commands in one line. So the next thing that I want to show you is what we call the pipe operator. So it's similar as the logic AND operator in a sense that we use it to when we want to do more than two things at once. So the pipe operator is used if you want to take out the output of the first command and use it as an input in your second command. For an example, say I'm here, I have my file, which is my script file. So I want to list everything that's there on the folder, and also like to see the permissions that I have and all the details that it shows. But at the same time, I want it to only show the file name that contains script in their name. So obviously I only have one script here, but you can use it if you have more than one script and you're just looking for a script which has scripts in its file name. So as you can tell, it's showing that. So in summary, there are two instances where you would want to use the pipe and the logical operator. You can also be able to use the logical operator as well as the AND operator in the same line. For an example, say you want to view the content that you have in your script. And then in that you want to grab the phrase "I can do it." So you can just pipe that. Say you also want your operators, your OS to tell you that it has found the phrase "I can do it," then you can just put the AND operator echo. So as you can tell, it's telling me that it found the phrase successfully. So I'm just going to go through the questions. Okay, it seems like the question has already been answered. So now we're gonna move on to another way where you can use the terminal to perform multiple tasks at once. So I want to show you a concept that I found really useful, and it has helped me in doing like tedious jobs. So yesterday, Isabella asked if you could touch on for loops. So I'm going to do a very brief introduction to for loops. So I'm just going to do a demo to see how it can help you in situations. So I'm also going to be touching on if statements. I'm not sure if we've heard about them. So say you want to browse the contents of each file in a certain folder. So you want to know what each file contains without having to open them one by one. This is one of the things that seems like you would want to write a script for them, because it's something that you would want to do again and again as time goes. So the first step would be to choose a text editor that you want to use. So I'm just going to stick to Nano, as Benjamin has been using it throughout. I'm going to create a script that's called so the first thing that you would want to do is obviously tell your system which interpreter it should use. As I mentioned before, I'm still going to be using Bash. And then the first thing that I'm going to do is specify my directory as a variable. So I'm just going to put the full path. So this directory is the directory that contains the files that you want to view the contents of. So one thing here, I think it's best to use your full path instead of your relative path, so that your script can work no matter where you are in your system, like if you want to copy it to another directory. So the first thing that I want to check is if my directory exists, I would want my system to print something on the screen. So there I'm gonna use my first if statement. So the D just stands for if it just tells the system that if it sees that this directory exists, then it's gonna echo that it's processing the files inside your directory. And then the next step is that I'm gonna use my, sorry. I'm gonna start with my for loop statement. Sorry. So I'm just gonna explain the code once I'm done, because explaining it as I go is gonna be kind of confusing. No, I thought I was typing this whole time. Yeah, I'm just gonna copy and paste it. Yeah? Yeah, yeah. Okay. So I'm gonna try to extend the code now. So the first if statement is just there to check if the directory exists, and also if it finds the directory, the one that I specified there, then it's gonna equal that it's processing files in that directory. So the for loop, this whole statement, all it does is that it goes through the directory and then displays all the files that are inside the directory. So you're gonna see when I'm writing it, how it displaces the files. So say now you don't wanna, sorry? Which command? So the if is called, the whole if echo is called if statement. So that's what we call it. Oh, read it. Read it in English. Okay. Okay.
Then
Yeah, so you know what echo is for, right? The command echo. We did it yesterday. So the command echo is just gonna display on the screen where the code is, like for an example here. So if the system finds the directory which I specified here, then it's gonna the output is gonna be this line, processing files in this directory, but it's not gonna say in this directory as a variable, but it's gonna write the full path of the directory. And then the next line of code is what we call for loops. So what it does is it goes to this directory. It goes to this directory, and then depending on what you put as your perform operation, it's going to do exactly what you put here. For an example, what I have here is just copying the files into a new directory, like maybe creating a backup directory. I'm gonna go here because the main point that I wanted to show was to display the files. So I see here that I have an incorrect line of code. So what I want is for the script to just display the files on the screen. So I'm gonna use the command called cat, and then it's just gonna display all the variables inside file. Which I specified here. So if and for loop statement are very complicated when you're just looking at them, but if you keep on practicing on them, it gets easier and it makes more sense the more you practice on them. They start making more sense. So if all fails, like let's say the system finds that this file doesn't, this directory doesn't exist, then it's gonna echo the directory is not found. This directory, let's say my path is incorrect for an example, then what this line is gonna do is it's just gonna say the directory is not found. So I'm gonna save my file, and then I'm gonna execute it. So I'm gonna use the change mode, because if you can check, I'm sure it's not executable here. And then I'm just gonna change it. And then now I can be able to just run it. this work. Okay, so it means that the directory that I put the incorrect directly. I'm just gonna go back to my file and correct that.
Go back to the console.
Okay. So I made a mistake here by putting my project twice. I'm just gonna correct that, because then that's the reason for the error. Oh, clear skin. It's good. Is this gonna move? Sorry. And I'm just gonna run my script. So one thing I need to do so that you can understand right fully the function of the for loops, I'm just gonna copy my, because I realized that I only have one file here, and two files. I'm just gonna copy my script file, maybe copy it 3 times so that you can see. I'm just gonna add more files onto my directory. So I'm gonna go back to using my logical AND to just copy my file maybe 3 times. So I'm just copying my script .sh 3 times. So now I have 3 of them. So I can now run my script, which is viewing the content. So it should, if it works, it should display all the content of each file. So I'm just gonna go up. So here it's saying processing file, which is the first file, which is my script 1. And then it's showing what's inside the my script 1. And then the second part is processing script 2. And then it's showing what's inside script 2. And so on. And then the last part is just the script that I'm using currently. So yeah, it's processing that. Yeah, I think I'm done. Sorry, I can't. I mean, you can put an extension, yes, it does, but it works either way. But obviously, it's smarter to put an extension. Yeah. So we shouldn't do it then. Yeah, sure.
Share screen.
So another thing that I wanted to show you is the notes that we've translated to 3 different languages: isiZulu, isiXhosa, and Sepedi. So they all on Git. Just to accommodate everyone, we've decided to translate the coding notes, like every content that we've done throughout the week, into isiZulu. So you're just gonna find it under the report CSS 2024 notes isiZulu. And then, yeah, you can find all the content that we have. If you prefer to read it in your own language, then yeah, we've provided that option.
Teto, do you want to present your content?
Okay, good. Thank you, Chair. Bantwana bahle, msikantu. Utata uRholihlahla Nelson Mandela once said, if you talk to a man in a language he understands, that goes to his head. If you talk to him in his own language, that goes to his heart. The quote underscores the significance of linguistic and cultural connections in building meaningful and empathetic communication. Bantwana bahle, this is not easy. This is not trivial to achieve. I can confirm that using a closer dictionary, the internet, and my own knowledge of the closer language has not been sufficient to attain the desired outcomes. Although progress is being made, collaboration with Bantu linguists, Bantu poets, and anyone, even yourselves, who can assist us in achieving this novel goal will be helpful. For example, determining an appropriate translation for the term source code. Yikhodi yonikezo okanye yikhodi yemvelo. This poses challenges as the word code does not even exist in my closer dictionary published in 1903. Similarly, the term supercomputer. Ikhompyutha enkulu okanye bubuxhakaxhaka becomputer. This requires careful consideration. So if you can provide assistance with any of these translations, please reach out to us on Slack. Due credit will be given for your inputs. Ndiyabulela nto zakuthi. Masibuyele embo. Masibambisane, masakhane. Enkosi, I thank you.
Thank you so much, Teto. And just to recap the notes, if I just share my screen. Here. You'll find the notes for Suzulu, Siklos, and Sepedi. My colleague Sam Mateja, he's on leave today, so I can't present it. But we have notes translated in all these three languages. Might be some delays in some of the notes, but you can click on these links and just check for updates. Thank you for the team for doing that. Okay, so just give me a minute or two. I just need to set up my monitor, and then we'll carry on with today's lesson, starting with Jupyter Notebook. So just give me about 2 minutes before I set up. Okay, I'll give you 5 minutes if you want to walk around and stuff. So say in 5 minutes, we'll start again. Okay, I think we can carry on with today's lesson. And today's lesson is going to cover quite a few topics. So I want to cover as much as possible just to make sure everybody can maybe learn something extra, learn something new, and make it, worthwhile in for week 1. So today we are looking at quite a few things. As I said, we're looking at Jupyter Notebook, how that works, why do you want to learn it, and how it might benefit you, especially for week 2 next week, because some of the lecturers will be using Jupyter Notebook and not Spider. Okay, so let's just first start off with getting this up and running and see how that works. Okay, so up to now, we've been using Spider for our Python coding environment. And I hope you're now familiar with it and can see why it's useful. But many times, a lot of tutorials you'll see online, they're written in a Jupyter Notebook or Jupyter Lab for the simple reason that it's easy to visualize content and explain your code because it's a mix between HTML, JavaScript, as well as Python. So it's all a mix of various languages together that allows you to present it in a way that's very visually appealing and allows you more customization. So almost like a Word document that you can add pictures to it and code and run the code at the same time. So it's a mix of a few things. But it's useful to learn how to use Jupyter notebooks, especially for week 2. And again, there are many other types of environments you can run Python in. So other popular ones are VS Code and PyCharm, and there are many ways you can run Python. But today we're going to get to understand a bit about Jupyter Notebook and how to run it. So you have some idea about that. So we're going to open up Anaconda again. So if you go to your Windows Start and you just type in here Anaconda, you can go to your navigator if you want. We click on your navigator. It'll open up for you your Anaconda environment. So mine's is loading, so it takes a bit of time. It should appear shortly. So we can begin. You can actually just type Jupyter Notebook as well if you want. You don't have to go through the whole route of and should type Jupyter as well. It should pop up there. So either go through the Anaconda or just type in Jupyter. It should pop up there as well. So I'm going to just wait for the Anaconda environment to pop up. So as I said, just type in Jupyter Notebook and it should open up environment for you. Maybe I should have done that because my Anaconda is taking a bit of time to load. Yeah, my Anaconda is still waking up. I had a busy night last night, so let's give it some time. Wonder if I just actually type Jupyter, maybe that'll be quicker. It doesn't have to open up everything else. So if yours is open, so let me know if anybody has opened up the Jupyter Notebook. Can I get a thumbs up? It's open, so here's mine, just opened up the screen. So I went here, just typed Jupyter, clicked on it, and it should open up a browser actually, right? So it actually opens a browser, and this browser environment is how you actually going to be using Jupyter Notebook. That makes it quite useful because you can share it with other people and work with it. Okay, got thumbs up. So yeah, so this is our environment over here. And the first thing we're going to do is we're going to go to this, click on this drop down, say it says new, and you're going to choose a Python 3 option for notebook. So go to new, Python 3. And this is what you'll see, right? Any kind of notebook you'll see, this is how it will pretty much look, this environment. And what you're going to be working with is quite a similar environment to your Spider console, which is quite interactive. If you input things, add numbers or print statements, it's very similar to a Python console that we're used to. So it's a combination of console environment and a scripting environment, right? So it's something you kind of have to get used to. The other thing is you can add code and run it, as well as add text, add pictures and whatnot to make maybe your Jupyter Notebook, but more descriptive. So it's a very nice way to present content. You'll see it next week as well. Some of the lectures will be using Jupyter Notebook. They have their content with pictures describing concepts and then running the code just below it. So you'll see the output. So let's just get things working here. We can click on this area, which is called a cell. So Jupyter Notebook is separated into cells that you're going to work on. So if I just click on here, we can see our cursors running. And let's start with what we've been started with at the beginning of the week with the print statement. So I can say print hello world. Hello world. The first thing we learned with Python. And to run it, you can either click the run button or you can hold on Shift and Enter. Shift and Enter, right? So 2 ways to run it. You can either the run or Shift Enter. And you'll see what happens is you get a new cell that pops up, right? So it's almost like a new line that it creates in your console. So just like we did earlier in the week, we can do simple arithmetic, maybe like 10 plus 10. Right, Shift Enter or click on Run, and it runs it, and you get your output. Right, so very basic, something you're quite familiar with already with Python, the console inputs and outputs. Okay. So let's create a list, maybe like the age list, like we've done before. So to create a list, say age equals open square brackets, 10, 20, 30, 40. And 50, right? Just for example, if you press enter, you'll see that nothing actually happens because you can actually run a script. You can run a group of commands in your in each cell, right? So I can say print age as well. If I were to run it, I would say Shift Enter, right? So stores your variable and you can print something. All right, so getting used to the concept of a cell is quite important when you're working with these type of notebooks. It gives you a lot of freedom, but it's something you have to get used to as well. So I've done a bit of code now, have a few print statements and everything else, but what happens if I want to maybe tell a story? Like, why am I doing this? So you can use comments as well, like, this is my first Jupyter notebook, right? I can do that. That's all fine, right? But comments are quite limited to telling a story, right? So what you can do, you can click on this option, choose Markdown, right? And with Markdown, you can almost use like a notebook or a WordPad type of environment. You can say, you can use all types of fonts and formats to tell your story. So say this is my first notebook. Okay, probably can like highlight it as well, make it whatever you want to add, right? So one thing that is quite common is to if I want to take a picture of my current environment, I can do like maybe take a screenshot over here and paste it. So any images you want, if videos as well, you can actually paste it in your cell. So in your notebook, you might have code that you can run. You can have text, you can have videos, anything to actually explain kind of a story that you're working with. Okay. And there it is. This is like some text I had and an image I added. Right, this is an actual image, right? If you want, maybe that image isn't very, looks like everything else is. So maybe let me take another snapshot of something else. I'm still I'd go to Markdown and maybe paste this image I have here of a tent outside. So Shift Enter, and then I'll have an image of the tent somewhere outside. So I can have code, text, and images, right? So you can start building up your story of some maybe research you want to describe quite nicely in a Jupyter notebook, right? Because it's a mix of both. And just remember that this is not necessarily a Python file. This is a Jupyter notebook file, right? So we're going to do this a bit later, but if you download this, it doesn't download it as a Python file. It downloads as a notebook file. And the content you'll see if you look at that file is not Python. It's more HTML and JavaScript and more web-based content inside. But again, it's very useful to getting familiar with this type of environment, because you can tell a story quite nicely and teach nicely as well. So let me look at a few examples here. So what's the difference between a Python file and a Jupyter notebook? Raul, so they're completely different. They're not the same. We'll look at a Jupyter notebook file that we've downloaded a bit later, and you'll see it looks nothing like a Python file itself. How do I add an image? So if you have any add an image, you can there's a lot of options here to do it, but I just copy and pasted one. I took a screenshot, so screenshot of anything really. So screenshot over there. So copy an image from your clipboard, or copy an image, stores in your clipboard, and just paste it. But remember, for images, you have to go to the markdown option and paste it. So those are images, okay? But by default, each new cell is going to be a code cell. Yeah. Sure. Yeah, so just remind me a bit later, Andrew, about exporting the Python code. Yeah, that's something worthwhile to note as well. Okay. So let's maybe do something a bit more interesting. And let's go back to our good friend pandas, right? Hopefully, you're quite familiar with pandas, and we can use it here as well. I mean, that's really the idea behind it. So let's now look at let's now see if we can use pandas. Okay, so let's say import pandas as PD. Remember, shift enter to run that cell or run that line, and it didn't complain. And let's get a file that we are familiar with, right? So our country data. So let's see where this file is actually first. So if we say our command, which is pd.read CSV, country data. Country data.csv. I'm actually doing this cell by cell, but you can all do these commands all in one cell as well, which we can show you afterwards. Okay, enter, and then compare. There you go. So this again should be very familiar. Nothing new here. The country data was in the same folder as my Jupyter notebook file, and I could print out the contents here. So once you're working in Jupyter notebook, you don't actually have to use a print command to output any content. I can just say df as well, and I'll get it in a maybe a bit of a nicer format as well. So just remember that this file is relative, right? It is assuming that my Jupyter notebook is in the same location as the country data. If it's not, you have to add the correct location, the absolute path, like where it is maybe on your computer, or relative path if it's maybe one folder up or down. Okay. how do you add the file on Jupyter? How do we set a working directory in Jupyter? So if you say if you say save as, okay, maybe not, don't have to do that relative to notebook directory. We don't need to do that just yet. Or we'll go to the creating a directory and whatnot just now. Let me just quickly finish the the examples of just using this for the time being. So one example that I want to show you as well is plotting, right? So can somebody give me the code to plot, right? Maybe give me a line plot, maybe of the age column. I'll import the library for you. So import a matplotlib.pyplot plt. So that should work as well. Give me a line of code that will, just like a line plot for that one in the chat. Okay, we'll go through the we'll go through that now. So just everybody's asking about the directory. So let's go back. Let's go back to our home page again. All right, so let's go back to our home page. So just like you created a project in Spider, we can say, let's maybe create a new folder over here. Show where the folder was created now. Probably about new folder. There we go, untitled folder. So let's see if we can rename it. How do you rename a folder now? There was an option before, but in any case, let's say you've created a folder before, or actually let's go back to our previous directory where we had all our folders before, where we had day 2, day 0, right? So if, for example, we click on day 0, day 2, we had all this data before, right, that we worked with. And we know that we have our data folder here as well, Irish data and everything else. So assuming we have this folder already, let's click on new and open up a new Python terminal of Python notebook. And let's save it. So save as, and you'll see that this is the path that we're currently in, the folder that I chose. So I'm going to say this is the path that I'm in, enter path relative to notebook. So maybe say what should be saved as? This should be saved actually. I'm already there. So it is saved actually there already. Let me just show you in my folder. I created already. So let me just show you over here. So this is a folder that I'm working in, and there is the notebook. Right, we can rename it again, but there's a notebook that we can use, and we know that we're in the same folder as everything else, with the data, with our Irish data and everything else. Okay, so that's how I can make sure that your Jupyter notebook is in the same location as everything else. So let's look at maybe the Irish data. We can say import pandas as PD. And I'm going to do everything in one line here. So it's in df say df equals pd.read CSV and iris.csv. Sorry, CSV, and then just set df. So this is all in one cell and putting in code. So it's almost like a script that we're running, right? Let's say if I run it, and you see the output of the iris data. Okay, so can somebody give me a plot? If I import everything, if I import the plotting for that, so import matplotlib.plt as plt. Can somebody give me, oh, sorry, it's supposed to be pyplot. So I can go back to a cell and correct it. So pyplot, run it again. So can somebody give me a line of code to maybe a line plot for sepal length, for example, just a line plot. A line plot in the chat, please. Okay, so plt dot plot plot df sepal length. Okay, and then plt dot show. There you go, to plot. So you can see that this interface is a lot more interactive, and you can explain concepts a little bit easier to other people when you're trying to teach concepts, or even if you have a story you want to share it, it's quite nice that way. So this is a Jupyter Notebook in a nutshell. Now there's an upgraded version to Jupyter Notebook, which is called Jupyter Lab. And the interface is a lot more user-friendly in terms of your files and where it is, right? So a lot of people have been asking about where's my files and folders. Not sure where it is. Like in Spider, we can clearly see where files and folders are. So if you go back to Windows, just type here lab, with Jupyter Lab. Okay, probably have to open up Anaconda for that then. So if you open up your Anaconda environment, Anaconda Navigator, hopefully it won't take too long this time. I'm going to show you an upgraded version to Jupyter Lab, which is called Jupyter Notebook, which is called Jupyter Lab. And in that sense, you can see your files and location of it all in one place. Because I know that is an issue. This is a with Jupyter Notebook itself. Let's give it a moment while it loads. Can show you that. Okay, while Anaconda is deciding to do something, let me just carry on with a few more examples as well of just using the Jupyter Notebook environment. Okay, so in the notes, I gave two numerical calculations which I added here, which just explains to you how to work out standard deviation and R squared. I think somebody asked about R squared last week. So there are libraries that can give this quite easily to you, but just for the sake of practicing Python code, you can do this manually as well. And through that, you'll see all the benefit of, all these libraries that have been done for you, so you don't have to do this from scratch. But I like doing this in any case, just to kind of get a better understanding. If you can do things from scratch on your own, you can understand the concepts a bit better. Right, so see if my Anaconda is up and about. There it is. So this is what I wanted to show you earlier. If you open up your Anaconda Navigator, you got all these options, and I'm sure everyone's familiar with Spider, which you probably used before. And the one we've used now, what I've introduced is Notebook. Okay. But what I want to show you is using Jupyter Lab, which is a nicer interface that shows you where your files and folders are. So if I click on Jupyter Lab, I'll need to wait for that to load. And again, that will also load in this will also load in a browser. All right, so if we go back to our folder we've been working with, we should create another one. Maybe let's call it 2024 day 5. Yesterday's the last day for week 1. So let's go click on this one. Nothing at the moment, so let's create a notebook. And we can rename it to, my file. All right, so you can already see this environment is a lot nicer than a pure notebook on itself, Jupyter Lab, because you can at least see all your files and where they are on the left-hand side. But everything else works the same. If I want to import pandas as PD again, let me just zoom in here so you can see. As PD, df equals pd.read CSV, iris.csv. This is going to give me an error, so I'll need a relative, either absolute or relative path. And then you see it's really complaining. Why is it complaining? It says there's no such file or directory. No such file or directory. So if I want to, so what I can do, I can probably go one up. I think the iris was here. And just to maybe make my life easy, copy path. Let me copy the path here. If that one works, now it probably needs a full path. Probably needs a full path, so it doesn't actually give you the full path. You'll probably need to do it like this. Yeah, there we go. Yeah, there we go. So what did the two double dots in the beginning do? Why did it work if I said the 2 double dots in the beginning? We learned this yesterday. What did it do? It's the same principles that is in a bash terminal. Yeah, I just went one directory up and I gave it the path for the iris.csv file. Yeah. Okay, cool. So I think they can go back to our folder that we're in. And this is where we are currently. Okay. So again, there's a few examples of, I wanted to do a few just numerical calculations that should show you just to work a little bit with the Jupyter notebook. So the one thing that we tried to do in the first lesson was obviously moving from Excel to Python, and a common, statistic that you would do is working standard deviation. Right, so Python itself doesn't have built-in function to work out standard deviation. But when we looked at pandas, we saw if we did df.describe, it has a built-in standard deviation calculation for you already. Okay, but now to practice certain concepts in Python, we can also work it out from scratch, right? So this is a coding exercise. I would like everyone to kind of follow me with to work out the standard deviation from scratch, just using Python itself. Okay. So what I'm going to do is comment. So I'm going to say this is an exercise to work out standard deviation from scratch. It's in Python. Without any libraries. So just want to see if that's pretty much it. So that's text, right? So I can add maybe like anything else I want here, like a picture or description of what I want to do afterwards. And then I can create a new cell. So this is a bit different to the Jupyter notebook version we saw before. If you click on here, we'll just add a new cell, right? And by default, each time a new cell is created, it is a code. It is code based. Sorry, it is a code cell, right? By default, it's not markdown or text based. So again, I just want you to follow what I'm doing. If there's something you're not sure about, I know we can discuss in the chat, but this is a coding exercise, a code along. Just follow what I'm doing and see if you get the same outputs. Okay. So first thing I'm going to do is I'm going to create an empty list. SQ for the diff list. Okay. Enter, and I'm going to create a for loop. All right. So if you don't know what a for loop is, just copy what I'm doing. I'm showing you the example of how to use it, right? So, yeah, go ahead. Sorry? Oh, is it too small? Oh. Is that better? If it's too small, it can also sit in the front as well. Okay. So I can create that, and then I'm going to use, I'm going to just copy and paste a list here for age. So it's going to be 39, 25, 29, 46, 35, 22, 49, 30, 40, and 30. So this is from the country data spreadsheet we are familiar with. Okay, now I'm going to create a for loop. So a for loop is just something, a piece of Python code that loops over each of these elements and does something. So to do that, I'm going to say for I in range, the length of the age, colon, enter. Anytime in Python you have a line of code and you have a colon, you say enter, you'll see that there'll be an indent. There'll be 4 spaces, usually 4 spaces, because this represents a new block of code that we're working with. It's almost isolated from everything else. Right? A for loop is something that runs continuously until it reaches its purpose. So what I'm going to type here is sqdiff is going to be the age of I. This means I'm accessing each value in the list minus the mean to the power of 2. So what does the mean? This is something I actually should have done before that. The mean is equal to sum of age divided by the length of age. All right, so we did work this out before in the first day using built-in Python functions like sum and length. We can find the sum and length of any list and get those results. Okay, so we have that. So if you don't know what this is, don't worry about it. We are working out standard deviation by hand. Okay, this is a formula you can look up if you want to. All right, so then I'm going to add this to a new list, and I'm going to say square diff underscore list dot append. So I'm just adding this to a new list for the one I created on top. Like that, and I can print out the results. So what does this do? Again, a for loop is an independent block of code. That's why we have these spaces here that will run for a certain amount of time. So let me, if I just maybe help explain that, I'm going to print I as well, right? So what'll happen is this will, I will print to the number of times that it finds in this age list, right? So we'll see what happens shortly. Okay, so now let's run this and see what happens. So that is shift enter. And we see that for the first index value, it goes from 0 to 1 to 2 to 3. And each time it's working out this new calculation, right? Working out the standard deviation. Well, not yet, but we're working out what square diff is. So this piece of code, this little block of code, it runs 10 times the amount of times that is the length of this list, right? So this block of code is running 10 times. It's an independent block of code. Okay, and then at the end of it, it's also storing that data into a new list. All right, so for example, let's print that out, that list, and see what it looks like. So we've stored all these square differentials into this new list. Okay. So now let's create a new variable, square diff equals sum. So we're pretty much finding the average of this list. Square diff list divided by the length. So pretty much finding the average of this list. And we can square root that. Square diff. And we should get 8.42. So that's the standard deviation we get. Now, this is, again, the manual approach for working on standard deviation. And just imagine you have to do this each time if you want to work out that statistic for a data set, right? It's quite a tedious thing to do. And with pandas, we were able to, with one line of code, we've got all the descriptive statistics. NumPy is another library we can use to that also has standard deviations as part of the it's one of its functions, right? So just want to make sure I have this correctly here. Okay, well, let me just take this. I shouldn't actually need to do that. I can just say import NumPy and NumPy.stdh. So with one line of code, I can work on standard deviation, and I need about maybe looks like 10 lines of code, maybe less, if I want to do it manually, right? So hopefully this gives you some idea of why we have these libraries, is to make our lives a lot easier, where they have all the stuff has to be done for you. So you can focus on what you really need to do. Work on the standard deviation for a column of data, right? So you can do that with any data set that you have. All right, so again, this formula or how I did that, you can Google it, the formula to working this out manually. That's not really the purpose. It's just to show you and to kind of follow me as I'm coding to kind of get the same result. In specifically doing this in Jupyter Notebook. Okay, so just try and practice that. Yes, you can use a while loop if you want. Not really necessary, but you can use for loops and while loops interchangeably in most cases. So yeah, so we're going to take a break now. We just went over our break, so we'll continue until 30:30. Yeah, so you can have your break now until 11:30, and then we'll continue on with Jupyter Notebook. Try this example. Make sure you're familiar with Jupyter Notebook and see how it works. Okay, thank you, everyone. Let's carry on. So hopefully you were able to play around with that example and get familiar with Jupyter notebooks. Okay, so I'm going to do another example. Again, I just wanted to follow what I'm doing. Don't have to worry too much about why I'm doing it or where do I get this from. So somebody asked about the R squared. How do you work at R squared? And that's just the statistical measure. Measures or represents the proportion of variance for dependent variable. So again, there is a library that can give you that if you want quite easily in Python. But because I want to practice a little bit about coding in Python, especially using Jupyter Notebook, let's just try and do it from first principles, actually. So you can Google it, see how you work this out on your own. But I have a code here ready to try it. Okay, so let's say, for example, I will be using NumPy for this too. So again, just code along exactly what I'm doing. So import numpy as np. Yeah. I'm not going to type this all out. You can actually get this from the notes, these two lists that I'm using. So you copy and paste these two lists from the notes. You can see it over here. You go to the notes, you can just copy and paste these two lists. I'm not going to type it out, but the rest I will. Okay, I'm going to create two NumPy arrays. So just like Andrew did for his introduction to NumPy, np it as array, hours, y equals np dot as array results. Wonder if I actually have given that. This is, if you are interested, this is pretty much what we're working out. It's R squared formula. If you want to know, if you don't, really doesn't make a difference. We're just practicing coding with me. Okay. So we're first going to work out the sum of that NumPy array. The sum squared. Sum of the Y array. That sum squared and sum of these two arrays. Okay, then find the length of the x-array, work out the top part of the equation, so this n times some xy minus some x times some y. The bottom part of the equation, find the square root of that, np of square root, and some x 2 minus np dot square x. Bottom part of the equation, part b, is np dot square root and some 2 minus np dot square sum of y. Then multiply them together, so the bottom part is bottom part of A times bottom part B is the bottom part of the equation. And then R2 is np dot square. So this top part of the equation divided by the bottom part of the equation. See what you get if we just type R2. I get 0.877. So again, what you're doing, you're just kind of following along what I'm coding, coding practice. There's very rare cases where you have to ever do this by hand, but it's a good practice to do in any case. So just like with NumPy, where we did the standard deviation from first principles, we did the R squared via first principles as well. Now, obviously, you're not going to do this each time. Why we're using Python is because Python has done a lot for us already. People have developed libraries that work out R squared for you. So in that case, we're going to use the one library that has done it for us, comes from sklearn, and you're going to be using that starting from Monday as well quite a lot with when you do machine learning. But you can also work that out quite easily. So let's import that library and see if we get the same answer. So for that, we say sklearn dot metrics import R2 score. And what we do is, okay, so R2 equals R2 score. That function we're using from sklearn is going to be the results and predict hours. So I first have to create a linear regression model. Before we do that, forgot that step. So to do that, we first need to say model equals np.polyfit. Results one. And this is our model. This is a linear regression model. np.poly 1D model. And if you type in R2, if it shows a star here, it means it's busy working it out. And there we go. I get the exact same answer as I get from using a manual approach of working out what R squared is. So again, this is just an exercise for you to practice first principles approach in Python. So you don't have to really know why I'm doing this, or have to do this in future. If you want to work on R squared or standard deviation, there are built-in Python libraries for that. So this is in the notes. You can practice it on your own time. Again, this is for code along practice that you need to kind of understand. In the notes as well, I also show you how to do more plotting, do a linear regression fit on the data. So if you want to see that as well, I'll just copy and paste that so we don't waste too much time. Let's paste that code over here. This is from the notes, so you should all have this. So I run this. PLT is not defined. Okay, so that's imported. So import matplotlib plot PLT. And again, match plot plot. If you see a star, this means it's busy running, and then get a scatter plot with a regression line. So the model is pretty accurate. It's quite a fairly good fit on the data that that we had. So it just shows the based on the hours you study, the results that students will get. So based on this model, the more hours you study, your results should increase. It's not probably entirely true. You can burn out and you can do worse, but it's just a very simple model and a very simple data set just to show you the principles behind it. Okay, so you can again practice that on your the notes are there, so you can practice it. So you can practice it. So one of the things of nice things with Jupyter Notebook is obviously you can now save this as in various formats. So it can save as not in that format. You can save as exported as a PDF, right? So if you have all your code and text and all the images, you can actually save this as a PDF, which is quite nice. And there are various other formats you can do it as well to share with other people. You can also create it as a slides. If you want to, somebody might do this actually next week where they actually use Jupyter Notebook as slides to go through the different sections. But there's various things you can explore here. But if you actually look at the contents of the file itself, if you look at the file here, let me try to open this as a open with Notepad. Let's see if this looks anything like the Python that you're used to. Does this look like Python? Does this look like Python at all? Definitely not. So if you attempt to do one of the projects and you submit a Jupyter Notebook, you'll get a donut. You'll get 0. Because this is not Python. Okay, if you know HTML, you can see some of these tags here. This is not a Python file. This is a Jupyter Notebook file represented in a browser. Emika, so I won't show that again because I have a lot to cover still. Quite a few people asked about automation. So I actually want to do that rather. If there's time later, we can go through the code for regression again. But it's in the notes. So we can have a look at that a bit later. And again, I might cover it again. So let me go through the next part. Zelia, the assignments or you mean the 2 projects? I can quickly look at that, but we don't forget it. So if you go down to week 1, you've got 2 project options. Option 1 is a movie database. You have to do some basic, just pretty much using pandas, do some ETL and EDA on the data and extract some insights. So you can do option 1, which is the easier option. I recommend for people that are new to Python. For people that are, familiar with Python, this is option 2, which is a Streamlit project. It's an open-ended project. The idea is to represent your research or your work that you do, present it on a web app using Streamlit, but it's permanent. But you write it in a Python code. It's quite easy to learn. Well, I expect you to research what is Streamlit. I can do a bit later today as well, but it's a very nice interface if you want to share ideas, your data with other people. Instead of sending them your Excel spreadsheet by email, you just send them a link, web link. You can open it anywhere, any device. That's a power behind browsers. You can open it to any type of device anywhere, and you'll get the same results. So this is why I recommend to use a Streamlit for the second option. But you can choose between option 1 and option 2. Okay, so hopefully that answers your question about that. Okay, there were a few questions yesterday just about automation. So I'm going to touch on that as well. We've covered most of the sections here about Jupyter Notebook. You can go over it in the notes if you want. And we did this numerical calculation. It's all here. I explained the various steps that you're supposed to do. And yeah, you get the results. And this one is about the linear regression, and you can plot it as well. If you run this code as is, take this code as is, put it in Jupyter Notebook, you'll get the same results and a plot as well. Okay, before we get to that, there are some issues with Jupyter Notebook. I don't recommend it for people that are starting with programming. But in any case, you should learn about it. It's a very powerful tool, and you'll see many tutorials online using Jupyter Notebook because it's easy to explain ideas and show code. But there's some fundamental practices that are kind of ignored when you learning Jupyter Notebook for the first time in programming. So the one thing is, as I say here, the code can be executed out of order, right? So when you first learned Python and Spider, everything was sequential. Like you're writing a recipe of instructions, one line after the other, your code executes, right? Or your Python will interpret one line after the other the code. A Jupyter Notebook gives you a bit more freedom. You're actually executing each cell almost as an independent piece of code, right? So that can be confusing, especially for those beginners. I mean, how does that all work together? Where are my variables stored? How do I, how do I kind of make it work? But that's why we started with Spider first and foremost, and not Jupyter Notebook. So as I said, also the order which the cells are executed can make it confusing to understand the flow of the program. Yeah, but you can, again, that's one thing. There are other issues, but I mean, it's since you have a foundation Spider ready, I mean, you should be able to transition and understand how you're supposed to code normally. Okay, the next section is automation. So again, there were quite a few people that asked about automation in Python and in Bash. So I'm going to cover that briefly. So what I've done is I've created 10 CSV files. Each of them have 2 columns that have random data X and Y. Okay, so we want to add up all the values in a column Y and store it in a list. All right, so you can do this in Python very easily, and you can do it in Bash quite easily as well. The complexity comes, or the choice becomes, once you want to do more complex calculations, it's more difficult to do that in Bash. Python makes it a lot easier to do those calculations. But the process of automation is very simple and easy in Bash or Python. Okay, so it's a choice you're gonna have to make at some point. So I'm going to first do the Python option. I'm going to go through the code and show you how it works. So let's open up. So have this, the CSV files are there. So first download and extract those files. So we can go there. So we go to home. Should be under day 5. CSV files. Download the CSV. Yeah, I'm going to extract it and put it in my project here. You can extract files in Python as well. You can do anything in Python. If you have any crazy ideas, please let me know in the chat of anything you've ever thought of doing. And you can probably do that in Python. Okay, so I'm going to copy my CSV files here. Oh, that's not nice. Okay, I have to go manually to the folder then. Where's my folder? Okay, there it is. So I'll have a whole bunch of files, 10 of them. And pretty much random data, 2 columns, X and Y. In each of them, we want to add up all the values in the Y column and store them in a list. So the processing is actually pretty standard. I mean, it's not too complex what you need to do. There might be a case where you want to do more complex calculations, then you have to obviously do something else, but this is just to show you the process behind it. Okay. So let's first try and read in one of the files just to make sure everything is working. Moment. All right, so let's see if we can read one of the files in pandas as PD. And df equals read CSV. It's in CSV files. I think it's file 01 or something like that. File 1. CSV. I'll check now. I'm missing double quotes. Let me run it again. Well, it's PD. I'll run it again. And probably the no file. What's it called? Oh, file _1. I made a mistake there. So this would be _1. There we go. Print it out. Now I get my data that I expect. Okay. So what I'm going to do is I'm going to copy and paste the code here. Well, let me actually type it out rather, so you see what I'm doing through each step. Okay, let me just move this away, the left sidebar. Okay, we need to import another Python library called OS, and that just allows you to access files and folders inside of Python. Okay, so import OS. All right, I want to create another empty, I'm to create an empty list. I want to just want to write everything in one cell. This one. Okay, so this one is going to list to store the sum of y values in each file. Okay, so sum list. Cool. And then we're creating an empty list. Okay, my directory where all the files are stored. It's going to be stored in CSV files. Okay, so what do I want to do? So anytime I want to repeat a step over and over again, I need a for loop. So loop through each CSV file in a directory. So for loops start with for, and what is the single file that I'm working with? I have to specify a file name. This can be anything. It can be I as well. This is a independent variable, a variable that is just used to store the that variable at that time. So I can say for, if we make it more useful, say file name. So at that for that specific file in OS. So again, OS is the Python library that allows you to access files on your computer. Right, so OS dot list directory. So this is a built-in function that allows you to list all the files in that directory. And it takes as input the directory you want to list. So, which I have there already. And before we get to the next step, let's see if we can print those files out. Make sure we everything is working correctly. So print file name. Okay, let's see if that works. Print if. I'm thinking of C there. There we go. I don't actually want this read CSV. This was something else I was doing. But we'll work around that, right? Because you might have different file formats, so it's not a problem. So just this piece of code allows you to run through all the files in a certain directory, right? This is all you need when you're speaking about using Python. Okay, so file name is a unique file in that directory. Okay. So the next thing we want to check, this is a condition. I see that I have other files in there. I've got a bash file, .sh and .ipynb file as well. So I don't want those, right? So I want to add a condition to say, I only want a file that ends with .csv, right? So if you remember from yesterday, we did all that like filtering with like file names and file types and whatnot. So in this case, we're going to do something similar. We're going to use a conditional statement in Python, which you have in all programming languages. And to do that, you use a built-in Python call called, or method, here we go. So well, call it if file name dot ends with .csv colon. So remember, anytime you have a line of Python code, for example, for loops and while loops and functions, you always need a colon at the end. And that just tells Python this is a unique piece of code that will run independently, right? And you'll see when you do that, an indent will appear to kind of block that code out on its own. And I'm going to print the file name here again and comment this one out. So comment that one out and just like that. So now what I'm doing is, again, I'm running through all the files in that directory. but I'm first checking if it ends with .csv. If it does, then print that file name. All right, so let's see what it is. There it is. It only prints the files that have .csv at the end. Obviously, you can search for other criteria. Maybe you're only looking for certain files at a certain date, certain year, certain month, or other criteria. Really, it's up to you what criteria you want to do when you're finding these files. Okay. All right. So now we know how that works. Okay. So the next thing is we need to use pandas, our good old friend pandas, to read that file. So we're going to say df equals pd.readcsv, and the file path. Now the file path is quite important because the file path gives you where that file is. So I haven't actually specified that yet. So I should do that beforehand. So under file name, print file name, I'm going to create a variable called file path. I'm going to say os.path.join directory and file name. So what I'm doing here is I'm just giving pandas the directory and the file name. So if I would replace that, for example, it'll look like .csv underscore files, and then, for example, the first file 01 .csv. So the directory refers to this, and the file name refers to that. And all this command is doing, only thing it's doing is it's joining the two. That's all that it's doing. Okay. File paths. Next thing, okay, now we got the data in pandas, and now we're happy, right? We're very, very familiar with pandas, and we can play around with it. We can work out the get the sum of column Y and append to the list. So we're just storing that value somewhere to use it later. All right, so I'm creating a temporary variable called total sum, which will change each time for each new file. And this is with what we've done before. Pandas has built-in functions to work out the sum, mean, average, standard deviation, all that kind of stuff. Actually, not standard deviation. Well, yes, standard deviation as well. Sum. So this will work out the sum for that specific column. And now I'm just going to append it to the list so I can store it and use it at some later stage. Sum list dot append. Okay, so enter. And you'll see once you're again in a block of code which is indented, which has all these spaces, every time you say a plus, then it thinks you want to write in that block, right? So this is one block of code. And this for loop over here is another block of code. Okay, but now I want to kind of exit the for loop and the if loop, because this I'm assuming should work and work out all my values. I want to go back to my original piece of code, my original line of code, which you'll see everything is in line here. Now, if I say print the sum list, print it out, let's see what happens. Okay, again, the for loop, it runs, it prints out each file name, and then it works out, the sum. Then at the end, we get the sum values and stored in a list, and we can do whatever we want with it, really. This is a trivial example, but I just wanted to show you how that works. Okay, and let's see if that actually is true, or if Python is telling us lies. Let's open up that file and see if 4945 is actually correct. Just opening up my Excel spreadsheet. Don't get me wrong, I still use Excel. I don't have anything against Excel. I still use it. But, once you want to do a lot larger things and automate things, it becomes quite tedious. But for quick things, I use Excel a lot as well. So this is that file 1, for example, and if I just click on this column, I see 4945, right? This also worked with the sum there for me. 4945 is the same value there. So we can assume everything else is correct if I got that one right. So this is how we were able to automate a very simple calculation and a whole bunch of files. And just imagine you have 100 files, 1,000 files. Right? This takes less than a second to do in Python. Imagine doing that manually in Excel for each file. I have to work it out and put it in another spreadsheet somehow. So obviously you can appreciate that this process is a lot quicker. Okay. So now the question is, okay, that's Python. That's really cool. I like that I can do that, but what happens if I'm working in a bash terminal? Okay, so just like normally showed us this morning, I'm going to do a similar process in a bash terminal. Okay, so let's go to that. I think I still have it here. So you can click on right-click, git bash. I have my super friendly git bash environment that we have come to know so well over the past 2 days. It loads. Thanks, probably tied. There we go. Okay, so I'm opening this up in the same location as CSV files because I did this already. Hello, Watayo. Why are the files not arranged serially as well? It really doesn't matter. It makes no difference if it's how it's arranged. We're going through each file one at a time. If you want to, you can do that, but there's no real reason why you want it serially arranged. But again, if you want to, if you have a specific use case, you can do that too. So I already put this code here, read CSV, but let's have a look at the code, see what it looks like. The nano read CSV. And unfortunately, this yellow text is terrible. Let me see if I can quickly just modify that for you. So yeah, I'm not gonna, hopefully you can see this yellow text. Find. Different color scheme for you. Okay, let's stick to that maybe for now, so you can at least see the code. Hopefully that is a lot better than having the yellow code pop up. It doesn't look so bad on my screen. I'm not sure why it's showing like that for now. But hopefully this is legible. So this is the same. This is the same, pretty much the same code, just in Bash. All right, so I've got my directory, just like what I normally did this morning. The directory location, I can use the absolute path where the files are, or the relative path. And I'm creating a list to store the sum of the wire column values for each file. I'll create a list. And then again, I'm using a loop. Now, this loop looks a lot more complicated than Python, and it is. The function is doing the same thing, but I'm not going to actually explain each of these lines, but I just want to show that you can actually do this in Bash as well. And you would most preferably run through your files in Bash, which is fine, but the actual processing, if it's quite complex, then rather do it in Python. Noko said on the chat, you open the script you were running in Jupyter Lab in Bash terminal. No, I opened, this has nothing to do with Jupyter Lab. This is Git Bash now. This has nothing to do with Jupyter Lab. This is Git Bash. So again, this code is on Canvas, so you can look at it. But what it does is it loops through each CSV file in the directory. It checks for, just like we did with the wildcard with the star, it checks in that directory if there's a CSV file only, and then checks if this file exists. If it does, then prints the file name. And then we did discuss awk, what awk does, how awk is a Bash feature that allows you to extract data from a file. And then I'm appending this data to a list and then printing it at the end. Yeah, Noka, I already had the script. I wasn't going to type it out. So I already had the script. I just opened it up in Bash. So I already wrote this before. And then I'm printing it out again. So I'm going to just check that can actually rather want to use absolute path in this case. Yeah. So let's run it. So I don't need to, I think I already did chmod for this file, so I can just run the file. So there it is. The code goes through each file, prints the file name and the path. And then at the end, it gives me, a list of all the values that worked out for each column, just like we did in pandas or in Python, right? The same thing, same process. So again, we had a few questions where people asked about, how to do automation, and this is an example of doing that, either Python or in Bash. And you have to kind of make up your mind, at what point do you do the processing in Python or in Bash? So in most cases, you would just do simple commands in Bash and just run your Python script several times. But I think I'll let Krishna, speak more onto that and examples he has probably. There's a lot more examples of that when running job scripts on a cluster. It can probably show that on his side. But again, this is just two examples of what you can do. There's one more piece of code I wanted to show you just on this too. So let me see what that file is. Here we go. It's this one over here. So I'm going to, it's in other directory. So let me go there. So we're on the same page. So CD J03, I think. So I wrote another script. I wrote a bash script that runs a Python file. A bash script that runs a Python file. Let's have a look at it. And that's pretty much it. Because bash is native, or it's building blocks for any operating system that you might connect to, like web server or cluster. This is where you'll control your workflows or your processes is with a bash script, right? So all I'm doing is I'm running the bash script. And what does a bash script do? It runs the Python file. So you can maybe separate the steps, and maybe in bash, you can run through the files, and then to actually process the data or process a file, you would run the Python file for that. If it's too complex, for example, to do in bash, then just do it in Python. So what happens if I run this file? Python sh. It runs, goes through each file, and works out, you know, the final column of data. Sorry, the list of data that we wanted. Right. So I showed you a combination of both now, bash with Python. Again, it'll depend on your use case, on your situation, when you want to, you know, just use bash, or maybe use bash with Python. Thanks, Jan. And I think Krishna will again maybe give more examples too when he does his presentation next week. But I'll let him rather do that next week. Again, and all the code is on Canvas, so you can practice it on your own. I gave the 3 different files there to do that, so you can play around with it. All right, I had another question about that pandas profiling. So we're going to use Jupyter Notebook again, because we are doing Jupyter Notebook today. We're going to use that as an example. But there's a few ways to do it, but I think the cleanest way, so it might not break your Anaconda's environment, is to create a new environment. Okay. So again, you can just watch what I'm doing. You don't have to do this yourself. These are the steps that you can follow if you want. So what I'm going to do is I'm going to go to my Windows and say Anaconda. Sorry, it doesn't pop there. Popped up there. Prompt. Anaconda prompt. Anaconda prompt. This is the one I want. Actually, I can do this in I should be able to do this in Bash as well. I mean, I don't want to show you another terminal now. Let me just rather do this in Bash, so we kind of all working on the same page, and you have to learn something new again. Too much learning isn't a good idea as well. Oh, it's actually should read that. Yeah. Okay, so what I'm going to do, let's see if this works in Git Bash. I'm going to create a new environment in Anaconda, and to do that, say Conda create name, say pandas 01. See if it works in Git Bash. Hopefully it does. Again, you don't have to do this. You can just watch what I'm doing. This is to show you how to set up pandas profiling in a kind of a clean environment. The steps I do have on the Canvas notes, so if you want to follow the same steps, you can. So when we saw the space over here in our Git bash, this refers to a Anaconda environment that was pre-installed for us. Let's press yes over here. So this is a clean environment. Well, that's an initial environment called base, right? So what I'm doing is I'm creating a new content environment, and I'm just focusing installing one specific library, which is this profiling library. Okay, it says to activate it as a conda activate Canvas R1. You can call it whatever you want. And you should see now that the space over here changes. Waiting, there we go. Now it changes to pandas 1. So now we're in a clean environment. We can, if you want to explore, play around with like other Python libraries, and you don't tamper with your original one, create a new conda environment, right? And a conda environment. You can Google about this, how to do that. All right, so now we've done that. So we have that. And now what we're going to do is I'm going to install the pandas profiling library. And I just say conda install, conda forge, double colon, y data profiling. Enter. And it's going to hopefully install that specific library. Yes. Yeah, the user interface in Anaconda doesn't actually have wide data profiling in it. You find it? Okay. Because I looked as well and I couldn't find it. Did you create a new environment? On base? Okay. I don't usually like filling with base, especially if it's like a new, like a niche type of a environment or library like this. So, and it's quick to create environment. It's just like if you know Docker, if you heard of Docker as well, it's like you're containerizing your workspace, so it don't affect anything else. But okay, I'm just look, because on my base I was able to install it, but I think I installed a specific version of this library. That's why it worked. But I mean, other people might have installed other versions that might have broken their Python or everything else. So that's that can happen. There's a question here: must we initiate Python script with WinPTI in all Linux terminals? No, it is only with Git bash. There's a reason for it. I don't really want to explain it. It's just going to confuse people. But all other Linux terminals, you just type in Python, either Python or Python 3, depends which one was installed. So I showed you yesterday, I think, when I opened up Ubuntu, I showed you like the matrix stuff. It did that. My PC is running out of space. That's why it's so slow. Okay, anyway. Sorry? Yes. Once it's installed, that's done. Just do it once. Oh, yes, yes, yeah, that's right. So you have to reinstall it, yeah, for a new environment. It's a completely fresh new environment, I mean, for each one. My PC is slowing down here. That's why it's taking so long. Okay, but it should install eventually, then I'll show you how it works. But yeah, so after the waiting for that to be done. So under the notes, I wanted to cover a few maybe useful resources. Show you the meantime. Some resources I wanted to cover, hopefully if we have enough time. So one is GitHub Desktop. So for those, again, that are new to GitHub, I only showed you obviously how to upload files and whatnot and save it in a cloud repository, but how to actually connect it to your local machine. So you can work on your code in local machine and kind of connect it to, like what you do with OneDrive or Google Drive, whatnot. So I've created a setup document to show you how to do that. Again, there are many ways to do that using Git Bash itself as well. But again, if you're new to this, on the general section, I added a setup for GitHub desktops to set up. So this installs software for you that will allow you to connect your local files to the cloud. I can easily commit and update, right? So I can go through this a little bit later if you want to install it, how it works. What you do is you just download it and install it. Once it's installs on your computer, again, this is unique for Windows. You sign up to your GitHub account, email address, whatnot. This was the details that I had. And then you'll see this window that pops up, right? So this was, once you're connected, this is the window that'll pop up, and you can select your repository that you created, right? It looks for it finds those repositories already on your cloud, on your GitHub cloud. And then that is obviously on your cloud somewhere, right? You have to download it, so to speak, to your local computer so you can work between the two. Now, we don't necessarily call it download when we speak about GitHub and Git. We call it cloning. So we cloning that repository, that folder, those files to your local machine. So I can click on any of them and say clone the repository. So I selected the first one over here for day one. And if you click on clone, then it will clone it to your local machine. And then what you'll see is there's busy cloning. And what you see is you'll have a folder with all my files and data that was on the cloud have now been, let's say, downloaded to my local machine. Okay, so all those files that are on the cloud are on my local machine. And now let's say if I want to if I edit any of these files, or even add a file, delete a file, for example, here, Notepad++, I added an extra line, for example, right? This is on my local machine. GitHub Desktop, if you go back to it, it says, look, there's actually, I saw the changes you made. Do you want to save it? Do you want to link it to your cloud, right? And to do that, if you want to save that change and make them sync between the two, you just say commit to main, right? You have a little blue button that pops up, says commit to main over there. And then it'll give you another option for which branch you want to put it to. So just ignore this. You just have, just say push origin. So that'll be the original branch that you created. And then there'll be nothing there again. It doesn't notice any differences. And then if you go to the cloud, before it looked like this, afterwards it looked like that, right? It added that extra line that I had on my local machine. I updated it, and now both are in sync, right? So GitHub Desktop is a nice way to, it's a go-between to make sure your GitHub Cloud and your local files are working and syncing together. And this is a basic, very basic workflow that you can use. You can use Git Bash itself, but then there are lines of code you have to, or commands you have to know what to do, but I'm not going to cover that in the summer school. But try out GitHub Desktop, just really connect the two. If you want me to go through a practical step-by-step of this, I can a bit later, maybe this afternoon, but all the notes for this is there. So if we go back to general, I did put that over there, GitHub Desktop setup. Let's see if my goodness is still not done. PC is taking a long time. All right, so there's GitHub Desktop, and then I won't do this at the moment. There's just, exploring Python. I wanted to show you a few statistics of, programming languages and various other tools you should look at. And another useful tool called PG Walker, which is similar to this profiling app I'm trying to show you, and then Streamlit too. But I think I'll leave that for after lunch. I'm not going to cover that too. And the last thing I want to mention is the CHBC Winter School. So the CHBC Winter School, I'll go through that after lunch too. Follows on in about usually August, sometime in winter. It focuses more on running job scripts, understanding what the supercomputer is. If you have simulations, if you have big data problems or big compute problems, how to run it on our cluster. And the other skills that are required to understand how that works. So running bash scripts. I mean, we only work in bash. Knowing bash is key part to running your files on a cluster or supercomputer. But that is specific to the winter school, and that's usually around August time, and that's completely online. It's an online course that's done by my colleague, Dr. Kevin Coble. Oh, finally, goodness. Great timing. All right, so that's installed. My PC is struggling to survive here. My C drive is almost full for some weird reason. That's why it's so slow. But in any case, let's try and get this profiling to work. Okay, so I'm going to open up Jupyter Notebook. I can type this in the terminal too. Jupyter Notebook. Should open up for me a notebook. Okay, so just go to new. I'm not really worried about where I am because I'm just going to copy and paste this code here. I'm not reading data from anywhere. So where I am isn't too necessary. Great timing for my PC to slow down. Let's see if we can delete something in the meantime. Okay, there it is. I'm just gonna copy and paste the code I have here. Pretty much what we saw from yesterday. I think no, or the day before. Okay, let's just first see if this or my libraries work. Shift enter. Yep, everything's fine there. And let's paste what I'm doing here. It's just random data. I'm creating random data with columns. I'm creating my own data frame. I'm creating my own data frame. And I'm calling using the reporting, pandas profile reporting, and I'm running this line here. So if I run it, then when you see the star, it's busy working. Doing something. Shouldn't take this slow, but my PC is decided to slow down. There we go. Okay, it's doing something. There we go. It's pretty much the same thing that I showed you other day. This is obviously just with random data, so you shouldn't really see any trends really. But that's how you can get wide data profiling to work. And again, this is just using Jupyter Notebook. Okay, I think that's all I wanted to show you. Hopefully that you can get it to work on your side. And that covers most of the content actually for week one. We're going to do a few more things after lunch. So let me just close this and close my Anaconda so PC gets some more RAM back. That. But I do need you to do one more thing before you leave. On yeah, so on the general section, I've just made this feedback form public. So please complete this form now before lunch. Oh, please complete it now. It won't take too long, 5 to 10 minutes. It's useful just to make sure we improve and any useful information for us to make it better next time. So please go to Canvas and complete this feedback form. It'll take you to a link to complete the various steps. It is anonymous. So please do that now. And then once you've done, then you can have an early lunch. And then we'll be back at 1:45. Dr. Krishna Govender will be presenting, will be our guest speaker for today. So please do that, fill in that form now, and then you can go to lunch. Thank you very much.